Okay, it's 9:30. Welcome to the DNSOP working group meeting, the first one of two. So the next DNSOP meeting will be on Friday. Next slide, please. So the chairs, Andre and myself here, Matt here, our responsible AD in the front. Schumann, our secretary, is over there. Peter is remote. And Jim, our technical advisor, I've seen him over there in the room. So, yeah, thank you. So we use Zulip/Meet Echo for our chat, Meet Echo, an on-site tool for this session. And of course, the minutes are there. Minutes are taken by Paul Hoffman. Thank you very much, Paul. Next slide. Note well. Okay, we assume, we kind of demand you to be aware of the note well. Okay, thank you. Next slide. This is an IETF meeting, so the note well applies to all the meetings and all email exchange for the IETF. So we also have an IETF code of conduct. It's also part of the note well, but we want to highlight this. These are kind of the basic principles of the code of conduct. Well, the summary is be kind and nice to each other. We work all as individuals and be respectful. We take this seriously. If there are any complaints, please reach out to the DNSOP chairs or go to, there's also an IETF ombuds team. Thank you. Next slide. Meeting tips. This is important for us. All in-person participants, please use the on-site tool or the remote, but it doesn't make much sense maybe. But do register via the on-site tool or the remote or the full client tool, because this is also the Blue Notes. It does register who's in the room and attending the DNSOP working group. Thank you. And for the on-site people here, if you want to go to the mic, you need to raise your hand and queue via the on-site tool. Okay, so this is also important. Next slide. This is agenda. Next slide. This is the regular update. Sorry, yeah, the regular document. So what have we done since the past IETF meeting in Madrid? There have been 2 RFCs published, compact denial of existence and the generalized DNS notifications, both in September. Thank you. There are a number of documents in the RFC editor queue. Yeah, I can name them, but it's clear they're waiting and they're making good progress. Okay, yeah, thank you. Apologies. And the last one is indeed CDS consistency. The working group call and at end of October, September, there was some edits after the working group last call, and they were good enough to submit it to the ISG with a request for publication. Thank you. Next slide. Good. So we had a number of documents waiting for the working group to go ahead. And as revalidation already had a working group last call, there was substantial feedback. So we asked for a revision by the authors. Authors submitted the revision in October, and we just kicked off Sunday the second working group last call for the document. It runs for 2 weeks, so please give feedback on the mailing list. And the authors are also here around, so you can also talk with them. Next are the domain verification techniques. Is on the agenda, and the authors and we think it's also ready for working group last call. But first, let's have the presentation. DNSSEC automation. It's planned for a working group last call, but there have been some edits and some ideas to update the documents and before we start a working group last call. So these, thank you. And continuing DNSOP Greece, it's on the agenda. Thanks. Next slides. These documents, yeah, they're waiting for their turn. There hasn't been an update. I think this, yeah. We will in contact with the authors if there's a new revision and when it will be presented. to make progress in the working group. Next slide. Yeah. This indeed, we had in Madrid, I think a 20-minute slot, 25-minute slot on DNSOP structured DNS error. We were looking for a path forward. Mark Nottingham also presented his ideas, or ideas of the authors. There has been some implementation effort progress, so maybe depending on the status, there will be an implementation update of Mark next session, not today. But we will definitely be in contact with the authors of DNSOP, DNS structured DNS error, and the authors of the other document to find a way forward. We will do that in the interim, and we're planning that December, January. Yes. Next slide. These are the agenda. So these are first, of course, we have the regular working group documents. We have 4 of them. I won't go all see on the screen which presentations they are. Next slide. These are the documents for consideration. 3 and another. Next slide. And next slide. So that are 6 documents for consideration. It's a full agenda, so we will be strict in timekeeping. Again, the authors, not many of them have 10 minutes. So it's up to the presenter to use 5 minutes for presentation, 5 minutes for Q&A, or the 10 minutes for presentation, but you won't have any Q&A. We will be strict. It's a decision of the presenter, but we will be strict with the 10 minutes and not overrun this time. Yeah. Thank you. We're doing fine with time. Yeah, we're doing okay with time. Schumann, can I ask you to give a brief update of the hackathon, and then we can start.
Okay, so I'm just going to give a quick update on DNS projects undertaken at the IETF hackathon over the weekend. So there was a bunch of people involved. We spread across 2 tables as usual. If you click on this link, you'll go to a short presentation which lists the set of participants and the projects they worked on. But they included things like implementation of DELAG in authoritative servers and maybe some resolver code as well. DNS transport signaling, which is the subject of a recent draft by Johan. There was work on integrating libuv and the quick support in the OpenSSL library for the ISC bind DNS server. There was also work on Poisonlicious, which is DNS resolver cache sharing. That was also for the bind server. And there was some work done in the post-quantum cryptography for DNSSEC Arena. There was preliminary work on MTL mode support for the ML DSA signature algorithm. And there were other projects done by a few people who are not at the main DNS table. So Yorgos did some work on dry run DNSSEC, and there was also work on DNS over CoAP. And if you go to the data tracker page for the hackathon, you can find some separate short presentations for those 2 items. So I think that's all it. If you have any questions, just follow up with me or any of the participants later.
Thank you very much. Yep. Thank you to all the people that attended and participated in the hackathon. Before I start, I want to make one remark still. So on Friday, we call it the liaison/dispatch section. There are 3 drafts from the ISE track, actually. But we want to present these documents here in DNSOP for the DNSOP working group to consider its work that should be done in the DNSOP or not. But that will be more detailed on Friday. But have an eye already on these drafts that will be presented on Friday afternoon or Friday around noon. That's it. Thank you. Okay, we can go to the first presenter. And
hello. Yeah. Oh, should I keep it? Hi, I'm Momoka, unaffiliated Next, and my co-author is Tobias. Hi, it's nice to be back at DNSOPs. I love how it's cozy here. Next slide, please. So, our draft is OSC 3901 bis. So quick recap to what OSC 3901 is. It's DNS IPv6 Transport Operational Guidelines. It was published in 2004, and what it says is for recursive resolvers, IPv4 only is allowed, IPv6 is not required, and for authoritative name servers, IPv6 is implicitly optional. So IPv6 is optional in 3901. And what we want to change is to not make it optional because this was written 20 years ago. Next slide, please. So why DNS IPv6 mandate is needed? So one problem is DNS fragmentation. Up to 40% of zones still is IPv4 only after 20 years since OSC 3901. And so for those zones, IPv6 only resolvers, they can't directly reach them because those zones are hosted by IPv4 only authoritative name servers. So for some names, IPv6 only name servers can't resolve them, and that's kind of sad. And I want to remind people about OSC 6540, published in 2012. It says IPv6 support no longer optional for IP nodes, and we want to do the same thing for DNS. So make IPv6 no longer optional for DNS layer as well. So current reality, IPv6 is now widespread. DNS policy, I guess, hasn't caught up, and it would be very nice if we can have a document that says IPv6 should be there for authoritative name service, so people can point to a document when people are having trouble when authoritative name servers don't have IPv6. Yep, next slide, please. So there were some concerns on if IPv6 DNS is ready or not. And at the last IETF at 123, Tobias did his presentation on how research shows IPv6 DNS is ready. So IPv6 DNS may have problems, but they are mostly because of misconfigurations. And by following ROCs and having good configurations, we won't be having worse outcomes compared to IPv4. Next slide, please. Oh, if you want more data about that, please check out the last 123 slides. And so we've made some changes since the last IETF. Some were fragmentation avoidance advice. So we quote RC 9715 and added those recommendations. And we also changed some wording on IPv4 and IPv6 translation techniques. And there were some other ROCs that were not referenced. So we've added reference to those as well. So, and we've also updated the draft yesterday, and we've also got some editorial comments for that as well. And we hope to we've incorporated that, and we hope to incorporate more comments we get soon as well. So next slide, please. So what we want to ask today is please read the draft again, and please tell us what kind of editorial things we need to fix, and please tell us if there's any major fixes we need. And the last thing we want to ask is, are we ready for last call? Is there anything preventing us from going to last call? Anything major we need to fix? And oh yeah, and another thing, do you support this draft becoming a document? Oh yeah, for last call.
May I?
Yeah, please, Tom.
Thank you very much, Mamoka. We are now at a point where we're starting to see, I think, wholesale, certainly within the United Kingdom, most ISPs are doing some form of IPv4 sharing, right? A lot of the biggest ones aren't, but that time will almost certainly come. We're getting to the point where the IPv4 quality across the internet will start dropping, and it won't be necessarily obvious to a very large DNS provider or something like that who've got plenty of IPv4, but it will be obvious, especially coming out of individual subscriber lines and things like that. So very much I support that this becoming a document and having these updates made. IPv6 is definitely no longer optional. We do need to make sure that that is written down. And I would also quite like to have an RFC that I can use to point at someone who's running a DNS server, an authoritative DNS server, and say, can you please do something about this? And it hopefully will encourage more people to actually think about putting quad A records on things as well, which we sorely need. So thank you very much. And yes, I please would support this to go further.
Jelinkova, IPv6 enthusiast. I did read the draft. I like it. I think the section about stub resolvers might need some editorial changes because, for example, using terms the mapped addresses, which are actually they're not mapped, they're synthesized. But my primary comment is actually about a part when you say it may synthesize based on prefix 4. I think you might want to add a reference to RFC v6 ops published recently about how you select the prefix, and it actually might impact your security consideration sections because it currently seems empty. It looks empty. And I think as soon as we start using synthesized addresses, and in general, right, for v6 devices, you need to say you need to prevent rogue arrays from appearing in the network, right? Because if attacker managed to send you a faked array, right, a lot of things could go wrong, right? So obviously you might point out that networks which have not been deploying IPv6 and now want to use IPv6 for as a transport for, as a network protocol for DNS might need to consider layer 2 security mechanisms in IPv6. It's kind of obvious thing, but you might just mention it and maybe refer to the security consideration section in v6 ops document.
To clarify, so yes, we should reference that RFC. Should we also write? Are you saying that we should also write more stuff in the security consideration?
You can at least refer to security considerations about like getting prefix 4 for stub resolvers and in general layer 2 security, right? Because you start enabling security IPv6 for your resolver, you need to make sure your IPv6 like is secure, which probably is most of the cases means your layer 2 security and preventing a random attacker sending you arrays.
Okay, thank you.
Jan, can you send the feedback on the mailing list, please? Yes. Because we will forget. Yeah, thank you.
Lorenzo Colletti, can you go back one slide? I see here like relaxed sub-resolver IPv6 prioritization from should to may. Does that mean that your previous text said that you should prefer IPv6 when talking to a recursive from stub to recursive, and now you might or you may? Is that something that we want to say? I mean, as Tom earlier made the point that IPv4 is sort of getting worse, right? And if this document is going to last a few years, we might regret that. Inside the No, it's not like address synthesis. I'm talking about prioritization here, but perhaps I don't understand. Do you want to take that?
So we had this discussion on the mailing list, and there were several strong opinions also going into the direction of even prohibiting either of the behaviors in each direction. So what was then ultimately settled on was basically the cop-out with May, because I probably am more aligned with what you would want to see. There were other strong opinions that didn't want to see that. So this was basically like the minimal possible consensus.
I would urge the working group to reconsider that, because in particular, when you're using something like DOT or DOH with persistent sessions, NAT timeouts will stall off your resolver's access to the internet. And then we see this. And, Android, you get this stupid notification that says, you can't reach your private DNS server. And you can tap there and it takes you to the settings because there's not much we can do. So I suppose we could implement, a quick session migration for this, but it just feels more expensive to use IPv4. Just another data point, my default gateway, which is an ISP supplied box, its NAT timeout is 180 seconds. And it's just terrible, right? So I put my phone on the table for 5 minutes and the DOT connection is gone unless we send keep alives, and the keep alives are very expensive. So we do need to shift this traffic to IPv6 if we can.
Thank you. And Lorenzo, can you also follow up this on the mailing list? Yeah, thank you.
Hi, Nick Braulio with ESNet. As is usual, Tom beat me to pretty much 100% of my comments, but I do want to say that in the US, in the small and regional service provider space, we have the exact same problems where there's not enough IPv4, CGNAT, and multi-layer NAT is becoming more and more of a problem. So I think this is way overdue, and I support it.
Okay, that was, yeah, okay. Then, okay, thank you all for your feedback, and please also follow up on the mailing list. Anyone else, of course, also.
Yes.
And yeah, thank you for your presentation. And I think after reading the feedback on the mailing list, we can go forward with a working group last call, and we will plan that.
Thank you. Please, everyone read it again and give us more comments on the list. Thank you.
Okay. Next presenter. Is that Eric? Is remote? Oh, Eric.
Is there a slide advancing thing? Okay.
Okay. Yeah, the slide is up, but we try to use the clicker.
Okay.
We're not successful, so.
So I'll be giving an update on the domain controlled validation, or DCV draft. Next slide. About a week before IETF, we published a -10 version of the draft that contains a number of updates based on discussions that we had back in Madrid. First of all, based upon some feedback, including around a draft on identifiers in the DNS, we merged in some of the thoughts from that, and also kind of based on use cases. So took what previously had been focused on as around random tokens and renamed that to talk about unique tokens. And for those unique token, and where random tokens is just one example of a unique token. And there's another thing we did is we improved some of the DNSSEC validation language as discussed in Madrid. We added a privacy consideration section, and we've started to read through and cleaning up language. Next slide. So there are a few open issues that we thought would be worth talking through here. Some of these we have preliminary versions of proposals that we've either sent mail on the list to or kind of merged into the Git repo, but haven't actually published on yet. I think one of the biggest open questions is how do we what do we want to talk about threat model here? There's been some discussion on the list on this front. I think one of the things that Paul Hoffman's been pointing out is that, and as well as others, is that we don't really talk clearly about a threat model in the doc. But there's also a realization that the threat models differ very based upon the application. Like the threat model that Acme is going to have is going to be very different than the threat model that some other applications implementing DCV may have. But I think one of the top things that we've kind of expressed here as part of that unique token thing is that the thing that you're really trying to do here is in DCV is demonstrate a causal relationship. And that's one of the main security properties. In that context, we used to have a must on having 128 bits for random tokens. We're proposing going and getting rid of that 128-bit requirement, and instead encouraging applications to select a size based upon a threat model appropriate for their application. So I think the question for the working group is, does this seem reasonable to remove any guidance around particular token sizes, and as well as is what we have right now in terms of expressing kind of the threat, not really having a formal threat model and leaving it up to applications adequate, or is this something that we should go and expand on and kind of build a much more formal threat model within the document, which would substantially delay when we'd actually go publish. Thoughts on this? I see there are two people in the queue.
I guess I'm up. Yeah, I think this document desperately needs a threat model, because I think for the most part, it's once again, we're putting a heavy steel door in a cardboard box. I mean, and I believe that the typical threat model for these things is that somebody wants to set up an account somewhere and wants to demonstrate that some domain, that they control some domain. So they get a token out of band. They put the token into the DNS, and you're done. So one threat model is that somebody who hasn't actually seen the website can display the token. So for that, you need a token that's hard to guess. But the reality is that the more realistic threat is that somebody goes and gets the token, and they're going to go hack into the DNS, which is totally outside the scope of this. And so for the typical case where you need to be able to show that you've seen the thing, you basically only need enough bits to make sure that it doesn't accidentally collide with some other token you've handed out to someone else.
Mm-hmm.
So I think it would be very useful to have a threat model. So here's a typical threat model. There may well be other cases, like when you're doing certificate signing, that you want higher security. And indeed, for certificate signing, they tend to have long keys, and they tend to rotate them every time they validate them. But I think without a threat model and some way to tie it to the amount of security people actually need, this is just going to end up looking silly. Because I can tell you, if you look at the typically overloaded zone apexes, where people have 100 different things from random email providers, they have, I got the number of bits wrong, but it's on the order of like 15 bits of randomness. And for them, that's plenty. All they need to be is demonstrate once that you saw the token. So please put in a threat model. I don't think it's super hard. I think it will make it way more useful for people to actually implement stuff.
Jim Reed, I pretty much agree with everything John has just said. What I would say is have some kind of understanding of what the threat model is, or what you perceive the threat model to be, would be useful for this document. I don't think it's a good idea to talk about specific musts on the size of the tokens or how many bits of randomness are needed, because we don't necessarily know, because that will depend on the individual application that someone's going to use there. What might be helpful on the other hand, though, is documenting the trade-offs between having, let's say, 16 bits of randomness as opposed to 128 bits of randomness, and allow people to choose what's the most appropriate size for whatever it is they're trying to achieve. But I don't think this document should be prescriptive in saying how big or how small those tokens should be.
Thank you.
Paul Hoffman, really briefly, because there was the question of is working group last call done or ready or whatever, absolutely not without the threat model.
Okay, next slide. So I think the other big issue is whether or not to reintroduce the multi-account section that we had before. The concept behind this was being able to support multiple intermediaries or multiple accounts. So, for example, if you're doing Acme for certificates, being able to have two different active sets of tokens, so that you could have two different domain control validations going on in parallel. This is most relevant when you have multiple intermediaries you're using. Acme has a instance of this in one of their drafts, and I think the question, we had taken this out because it had been a substantial amount of additional complexity to the draft. But there's been some people suggesting that we should put this back, put a trimmed version of this back in, because it is actively in use. So I think the question for the working group is, do we add this back in, probably as a trimmed down version of it and smaller than what had been there, or is this something that we should split out and publish as a subsequent draft?
Shimon?
So this is Shimon. Disclaimer, I'm a co-author on this draft, but I'm one of the people who argued to put it back in because, as you point out, it's out in the field, it's being used. And I just want to mention it's not only Acme, I've seen it for other applications too, where they want a cloud provider-based application that can host multiple accounts for an organization. They want to be able to authenticate the DCB assertion from multiple accounts. So I think this is needed.
Great, thanks.
Yeah.
Anyone else in this? Okay, next slide. There's some feedback that Stefan Ubank put in. We've most of these, when we went through these, ended up being just kind of minor changes. So we're going to include these in the next draft. And I think some other people have been in the mailing list have also been sending feedback. So keep some of those suggestions coming, and we'll fold those in. Next slide. So other comments, I think based on the Mike comments, it sounds like we definitely want to get a threat model in before working group last call. So if it's not ready yet from that perspective, we'll try to get that in before and as well as some of these other minor comments, and then publish another version. Any other comments people have? Great, thanks.
Yeah. Thank you. And yeah, looking forward to the threat model in the document, and that we can make progress, go forward with it for the next. Oh, sorry. Is that me? No. Yeah, this is Andrew. Okay. So, but yeah, I asked the authors to include the threat model and make progress, and that we can go forward with working group last call in the next months. Thank you. Okay, next is Andrew Kaiser, DNSOP integration.
Yep, and thanks, Benno. Andrew Kaiser here, presenting remotely here on updates to the draft integration of DNS domain names into application environments. Could I go to the next slide, please? So as a reminder, the draft's current focus in the document, the goals for the document, and this is text taken from the document, is to minimize conflicts between the global DNS and applications that integrate with the global DNS, to provide a consistent user experience, such as unique identifiers across environments, and extend the security, stability, and resiliency of the global DNS when applications integrate DNS domain names. The current version of the draft provides informational, non-normative statements on both the motivations for why applications are integrating DNS domain names and considerations that applications should account for to minimize conflicts. And I'd like to thank all the feedback we received during the call for adoption and to the art and sector for their early reviews. A lot of this we've been able to fold into version 1 of the document. Next slide, please. So the updates we made between 0.0 and 0.1, we added text from the introduction and security consideration sections to the abstract to frame the document's goals earlier. Some of the feedback we received were that it was hard to understand exactly what the objectives of the document were because the goals are scattered throughout the document. So hopefully by pulling these into the abstract and earlier in the introduction, that can better define what the goal of the document is seeking to achieve. We also updated the intended audience section to focus on the applications providing DNS integrations and highlighted that the considerations, while informational, can still be used as a checklist in this document that applications can account for. This addresses some of the feedback we received that the intended audience section was also a little too broad, so we're hoping that by targeting the focus here, it better narrows what we're looking at in this document. And then we consolidated the motivation section from its own standalone component into the intended audience section. This effectively collapsed 4 or so paragraphs into 1 or 2 sentences. This was from feedback that we received from multiple parties that since applications are likely already using domain names or have decided to use domain names in their integration, they don't need a motivation section to do that or choose to do that. And this will allow us to better keep track of the document's focus on considerations rather than both considerations and motivations. We also made minor updates to considerations identified during the call for adoption and reviews to tidy up some of the early feedback we received. Next slide, please. So at the moment, the document has 8 current considerations. I won't go over all of these here today, but just as a high-level review, each of these considerations has somewhere between a paragraph and a half or so of content. They state at a high level what the consideration is and what challenges an application might encounter if they don't account for that. So for example, the domain name lifecycle highlights the fact that domain names can go through various lifecycle events, including transfer, deletion, change in record status, change in DNSSEC status, and things of that nature, that if an application were relying upon those but wasn't accounting for them in the future, they might have issues that run into the goals we previously laid out. And I encourage everyone to take a glance at these considerations. Next slide, please. So what are the next steps that we would like to see for version 2 of this document? We would appreciate additional feedback on the considerations we already have, or new considerations to include, or ways to combine existing considerations together. The document itself states in the introduction that we cannot consider all considerations for all possible application integrations. But the idea here is that we would like to achieve as much coverage as possible in this document, and that will benefit from community voicing about additional considerations to include. A second point we would like feedback on is that some of the feedback we provided was that the document should provide more normative or opinionated language on how applications should handle the considerations. This would change the document pretty heavily from its informational status right now into something that might be a little more targeted at specific use cases. But we want to hear feedback from the working group before we decide next steps on this topic. So thank you for your time, and if there's any feedback right now, I'd be happy to receive it.
Paul Hoffman, sort of wearing an ICANN hat, I keep hearing people talk about integration. And when I say, what do you mean? It then goes off the rails. This document has a definition. I don't think many people in the room have read the document carefully. I think it would be great. I totally support this document. Even if I don't like some of the definitions and such, this is really needed, but it's needed with agreement, rough consensus from this working group that their definitions are good and their suggestions are good. So I, even stronger than the authors, would say, please read this document, if for no other reason than when someone asks you a year or two from now about some integration, that they might understand what they're asking.
Thanks, Paul.
And a note from the chair, so this has been adopted, so the working group promised to review this, so please do so.
Okay. Anyone else? Comments, questions? No? Okay. Thank you, Andrew. And indeed, read the document and give feedback on the mailing list. Next is Peter Thomason, I think, remote? Yeah, remote.
Yes, hi.
Peter, I will pass the control to you.
So how do I actually advance? Ah, okay, now it works. Okay, cool. Okay, I'm going to give an update on the draft on operational recommendations for DS automation. So first, what has changed? No, sorry, that's second. First, the status. It would be good if broad consensus was achieved for how to deploy DS provisioning automation for those parties who want to make a new deployment, and to really make sure that there is not any concerns from parties who might eventually end up having to do with this stuff. We sort of did a roadshow over the last few months and showed this off and asked for feedback in various venues. So there was some ICANN related stuff, DNSSEC workshop, tech day, and so on and so forth. We still have to talk to the address supporting organization, which is essentially the RARs, who sometimes do DS automation for the reverse zone delegations. And yeah, so I will reach out to them too. Otherwise, we've talked to PTLD and Center and the Registry Operations Workshop. And all of that helped resolve a few issues that, yeah, got mostly settled. We also did a workshop at the DNSOP meeting in Stockholm pretty much a month ago, where we settled some of the remaining issues. And so as a result of that, here is what has changed since the last IETF. One point was about how to notify parties when there is errors, or maybe not only for errors, but also when DNSSEC is bootstrapped or maybe disabled, under which circumstances that should happen. The concern that was given in feedback was not mainly about the triggers of notifications, but rather that the old revision said that feedback to humans should be via email. So that didn't fly well, and we've removed that suggestion, and now it says that the notifications to humans have to occur according to the preferences established with whoever their contract party is, like the registrar or the registry. So that will probably scale better. Then there used to be a recommendation, and there still is, for authoritative name server operators on the child side to publish both CDS and CDNS key records, and not only one of them, so that they don't have to know which preference format the parent has. And a related recommendation was that parents should actually also be checking for both. Now that is gone, and the consensus was that that was not a good proposal. Third, there is a recommendation that domain owners should be able to inspect the current DS configuration through the portal that they use to manage their domain name. Because, you know, a key rollover could have, for example, been applied, and then the DS record could have been automatically changed. That still is a should. There also was a should that said that the update history should be visible there, and there were some concerns from registries. So now the update history is a may, and the current configuration still is a should. And finally, there were some, essentially there was unclear wording about when you should disable DS automation. So that essentially should only happen when a DS record set was removed manually. And so then apparently the registrant doesn't want automation. But that was phrased unclearly, so we've fixed that. That brings me to the open questions that we still have. There is mainly 3. So I walk through them and would really appreciate feedback. So the first one is whether registries should do DS automation if the registrar has no DS removal interface. So the monospace thing here is the quote from the draft. It says, in the RR model, registries should not perform automated DS maintenance if it is known that the registrar performs this function. Okay, fair. Or when the registrar does not support DNSSEC at all. And so some people think that registries in this case should be doing DS automation because that enables using DNSSEC for domains where the registrar doesn't offer a provisioning interface. So it can be used with domains that otherwise could not be using DNSSEC. But a counter argument, which is what I think is the stronger one, is that when the registry would do that and the registrant domain owner for some reason would want to turn off DNSSEC because they don't have access to their key anymore and can't sign a CDS record or whatever they want, then they cannot do it because the registrar has no interface. And so, of course, one could say, go ahead, change your registrar. But yeah, so this is the tension, and we need to come to some sort of conclusion about what to say about this situation in the draft. One suggestion from somebody was that perhaps if a registrar doesn't support DS automation, they could opt in for the registry to do it for them. Sorry, if the registrar doesn't support any sort of DS provisioning interface, then they could still sort of ask the registry to do it for them, and somehow that would be an opt-in solution. On the other hand, in my mind, that's almost the same as what the current wording is, because the current wording is, if it is known that the registrar doesn't support it, the registry, yeah, okay, whatever. So let's talk about this more. The second one is, initially, when you ingest CDS or CDNS key records as a parent, you are expected to apply acceptance checks, like whether the delegation would still be validatable after you apply the DS record set and stuff like that. That's currently only required to do when you actually apply a change, and you only apply changes that work. One question is whether the processing party should also be rescheduling these checks later, maybe after a week, after a month, after a year. I don't know. I personally think this is not the responsibility of the parent. When things break at the child side later, then that's not something for the parent necessarily to detect. But we haven't discussed this point as a working group yet, so it would be good to see if there's consensus that this should not be the parent's task. And then lastly, there is one open question, which is only editorial, really. There's an appendix which has old sort of ideas that we didn't end up finding consensus for. And yeah, so for example, that parents have to check for both CDS and CDNS key records. I think this appendix can go, but if folks feel like it would be cool to have it for context or something, then we might as well keep it. So I guess I'll remove Appendix C unless there is feedback here or on the list that this should stay. And otherwise, I'd be interested in discussion on the two other questions. Thanks.
Hello, Stefan Lubink, SIDN. Regarding your first open question, I would say a registrant always has the possibility to contact the registry to remove the DS. So I would say if a registry wants to enable it, let them. Thank you.
I don't know if they always have that option. I don't know if in the GTLD space that's possible.
Hi, Wes Herdiger. I think that the registrar space is an incredibly complex and diverse environment that changes constantly. And I don't think that you can really put it in a requirement like this, because communication has to happen between them to even know whether or not a registry and a registrar, are doing DS automation of any kind. So I think that the opt-in approach is, in my opinion, the only way that is an acceptable path forward, because there's no way for a registry to know, even 5 minutes ago, whether that feature was turned on in the registrar for either addition or removal for that matter, right? So the registrar should really be signaling to the registry, please do this on my behalf.
Thank you.
Okay. No more comments. Oh, there's one question. We do have some time. Victor, so please go ahead.
I wanted to comment on point 2, in that it's clear that a few TLDs have much better rates of DS validity than others. And it's almost certainly because there is some sort of feedback loop between the registry and the registrants whose DNSSEC goes bad, and then it's corrected. But I believe that that really only works for registries that have a direct connection to the registrants, like Brazil, where they're also often the registrar, and wouldn't necessarily be viable in the GTLD model, as you say, because ICANN rules may limit how much contact the registry can have with the registrant to address the issue should it come up, right? If you're rescanning, you shouldn't just turn off the DNSSEC silently, but then you need a way of reaching the registrant, and registries in the GTLD space don't have that as far as I know.
Thank you.
Okay, thank you, Peter. Okay. So next up is Paul.
This should work. Let's see if that's true. Hi, so I think I have the least contentious DNSSEC related presentation today, but I could be wrong. Well, here, let's just go, yep. BCP 237, which this working group put through, defines DNSSEC, and it just lists all of the core and the not really core documents. Hopefully folks have read it, either when we discussed it the first time or since. This has worked. That is, we are seeing people that are totally outside the IETF space when they say DNSSEC, they're pointing to this. So yay, thank you for having done this work. But that was 2.5 years ago. So stuff has happened since then. I'm keeping a new draft going, which is the one listed here. And the question really is, what do we want to do about it? We'll get to that on the last slide. There are some new RFCs that have happened in the last 2.5 years. Those are listed here. And we have obsoleted some documents, including, 8499 and 7958. So a new RFC would in fact have better pointers, some new ones, and would not point to obsoleted documents. And by the way, the main reason I'm standing up here is for this slide. We've got some really important things in the RFC editor's queue. They might have been published before today. They might be published next week, but they certainly will be published within the next few months. And that's all of the stuff we've been doing on cryptographic algorithm recommendations and such like that. These will be RFCs soon. We know that. I consider these to be more important than many of the other things that are currently in the definition of DNSSEC, because people read what is DNSSEC often not just to know, well, what are the parts, but what do I have to do about it? This working group, and by the way, I don't agree with a lot of stuff in these drafts. That's okay. The working group had rough consensus on them. That's something that a typical reader of this RFC outside the IETF is going to care about, which is, what do I have to do about stuff? Wes, do you want to jump in on that one?
Yeah, Wes Harder, one of the authors of those. Just FYI, they just landed in Auth 48, so they're really, really soon.
Right. So we might have these within a week. We might not, but yeah, these are going to be RFCs. And again, I consider these to be more important for a typical reader than, for example, how does CDNS key work and such like that. This is what's more actionable. And we also have some drafts that are currently in the working group, which we are hearing about and such, which may or may not want to be in this revised RFC. So I'm asking for working group adoption. That'll go through the chairs and such like that. But when do we stop, right? There are about, like we've got some RFCs and we're about to definitely have some more, as Wes said. But we're always going to have more RFCs from this work or this work group or whatever else comes out of Wes's work on what happens in, DNS for the IETF, or not working group, but his work. When do we stop? And what, like when do we want to produce an update? The answer might be soon because of that last slide. The answer might be in a while because we already have some things in the working group, queue. And the answer might be never because we're always going to have things in the queue. I think that was my last slide. Yeah. So anyways, I'm asking for, do people want this? And if yes, when? So you can do the queue. Yep.
Peter?
Hi, Peter. So about whether I want this, I prefer a registry for this, but it's fine. Assuming that we will do this sort of thing, I think it would be good if we had a cadence, like if we said we do this every 2 years or something, then we wouldn't have to discuss, there would be like a cutoff date, and then that's the updates that get included.
Great. And if we do agree on a cadence, it should go into the document, so people will hold us to it.
Yeah, sure.
Yep. Great. Thanks. Someone answer their phone, please.
All right. Sounds like the phone has stopped ringing. So Paul, my question was related to your question about when do we stop? So I think we'll never stop because the DNS protocol, including DNSSEC, will always evolve. So my question, I had the same thought as Peter, is this the best way to keep track of the set of protocols that define DNSSEC? And should it be, should it be something else like a web page or a registry or something? That seems like, to me at least, a better way of doing it. And my related question is, there are many protocols in the IETF. Are other protocol communities doing something like this? The only one, you probably know more than me. The one that I know of is SIP did it with the Hitchhiker's Guide, but they only did it once. They never did it repeatedly.
That's
But
because
in your case,
because IPsec did it
okay.
once and never did updates.
Okay.
And I was the author of that one. So,
okay, got it. So my question is,
I am familiar with writing these and then having them be a one-time thing.
got it, right.
Yeah.
So I'm questioning whether we should repeatedly consume the working group's time to revise this at whatever cadence we need to do to keep it up, or should we do this in another form that is not RFCs?
There are two reasons to have an RFC. One is to have the list, and that could be done, I believe, better other ways. But the other is to have that list findable and readable by people who want to know. And in that case, I believe we should update it so when they find it, it will be updated. None of those people are going to look in an IANA registry. Some of them will find the RFC. Is that enough for us to do the work? I don't know.
All right. Okay. I'm skeptical about that, but I'll wait to see what
I am
other
as
people have
well,
to say.
but we can't measure that. And a bunch of us in this room like to measure things. We can't measure how effective it was.
Hi, Paul. Joe Abley. I think.
Victor's.
Say what? Oh, sorry. I'll shut up.
Hi, Paul. My sense is that we should really do these things around, if possible, around major milestones, not just sort of smallish updates in DNSSEC evolution. And to me, what comes to mind is that when DELEG lands, the landscape will shift dramatically. And that would be a good point in time at which to update the reference, because it'll have significant impact on the rest of DNSSEC in terms of transport and finding name servers and figuring out, where you find the DS records, and all of that wonderful stuff will change significantly, perhaps, or at least I expect, when DELEG comes along. So if that's like in the next year or two, then perhaps that's a good point to wait for. If it's 5 years out, then, sure, we might do 2 iterations or another iteration before then. But it seems like that's the logical point to do it.
Thanks. I consider the previous slide to be a milestone for this working group. I don't know if it's that we now have a way of saying what algorithm should you be using. To me, that's a milestone. But Joe?
Yeah, hi. So I think this is a good idea. I like this being an RFC. I think that's better than a registry or a wiki or anything else more ephemeral. I like the idea that people can cite specific versions of DNSSEC in other work. So it's clear what the state of DNSSEC was when they wrote that thing. I think that's useful. So on the frequency, I think this sounds like the kind of thing where when there's a major version bump, you would publish a new document. We don't have version bumps. So, I mean, it's an analogy, it's a metaphor, but is that sort of feeling. When things become sufficiently incompatible or new, then we do it. I think that's better than doing it on a predefined cadence, like every 2 years or something. And my last thought was that this, for DNSSEC, this is manageable, and you've clearly demonstrated that this can be done because it's been done, and you're talking about doing it again. It would be great if there's a similar effort for the DNS as a whole. And I know that you've also tried to do that in the past, and it was dreadful. But I wonder whether at some point, not now, we could think about whether there is some kind of, whether we could have an alternative to citing 1034, which is a ludicrous thing to cite when we talk about the DNS.
Thank you. Fair. But just to be clear, IPsec and SIP also had milestones, and they never updated their equivalents.
Petr Špaček, ISC. I want to second Šimon's opinion that perhaps this is not the best use of working group's time. And I don't think personally that the updates are substantial enough to warrant new RFC. And also, perhaps we should look at the different even venues, not as the IETF, but like DNSOP or somewhere else, where they can be more flexible and it doesn't take like 2 years to publish document with, updates 4 lines.
Great.
So
one more.
I'm here
Very good.
without the chair's head. So I read the document, and I find it relatively easy to review and progress. So I don't think that it will consume that much of the working group's time to have this.
I hope not, because all it's saying is we've already done something, right? It's not suggesting anything new. So, okay, very good. Up to you folks on adoption whenever and such like that.
Yeah, summarizing indeed, given, well, it shouldn't take too much time. And the working group is in a good shape in the sense that we pushed out a lot of drafts already to the ISG, and there's room for adoption. Yeah, thank you. We will follow up on the mailing list.
So next up is Steve.
Thank you. I'm a little nervous, unaccustomed to public speaking here.
Sorry. I don't know. Is me take off? I think that may be spiral. We're not speaking in French or English.
Is that a fire alarm?
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Okay. Okay, so.
Sorry, Steve, it's all your time now.
Somebody didn't really want you to have this presentation.
Attention, this is a no-op.
Let me give a short summary. WTF.
Sorry, this is Peter. I think we are even 7 minutes ahead of time, right? So if you need time on site to figure this out, we're not pressured on time.
Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
So is that second attention really needed? Do you have any choice? Steve, I don't know if you remember, but I can.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
No, I'm stretching my legs. This is fine. I'm good.
You're good.
Thanks.
The water is awful.
I think whiskey, maybe.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
This is a DDoS attack.
Somebody have a long stick.
Well, let me just skip to the end. I'm asking for adoption. Everybody agreed?
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
I would presume Jay Daly is working on this somehow.
Yeah, there are people on the hallway walking around.
You're ahead of time, so
Yeah.
still have 12 minutes.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Apparently, the emergency button was pulled accidentally, according to somebody in the tech reporting, like secretariat. So we're probably not all going to die.
Okay, the pedant in me, who loves to disagree with Warren, we are all going to die, Warren, okay? If you have any news that's different than that, please publish your research on it, okay? But we are all going to die. That has been the thing that has, okay.
Paul, hopefully not today.
Statistically likely, not all today, certainly not due to this.
We are now investigating the cause. Please stand by for further instructions.
So shall we schedule like 15 minutes for fire alarm next time, just to be on the safe side? Okay, Steve, you're up.
Yes, as I was saying. There are several slides here. I'm going to try to keep this very condensed. This work was triggered, at least on my side, by observing Red Hat's decision to remove an older algorithm from its library. Reasonably motivated, but done in a way that caused quite a few problems for the people who were receiving messages that were still encrypted or signed with the old algorithm. So I looked around to see if there was specific, clear advice about sequencing of phasing in and phasing out cryptographic algorithms. Did not find exactly what I was looking for, so I sat down and sketched a life cycle, and the results are mostly obvious, but have a couple of key specific details that are worth bringing to the surface. So here's a one-slide summary of the key points. Vendors and operators need community-wide signals regarding when and how to phase out old algorithms. And also the phasing of algorithms in and out generally involves coordination with other algorithms. And finally, the details are a little more complicated than usually considered. So assessment of current deployment is a necessary part of the process. And as a result of that, it feels to me that an IETF managed registry with expert consensus is part of the solution. So that's the one slide thing. Now I'll take you through the rest of it. So these slides are intended to illustrate a life cycle for DNSSEC signing algorithms. Same ideas are applicable to other crypto algorithms. The simple part is obviously you want to have the receiving side checking for signatures or decrypting in place before you start signing. Otherwise, it won't do any good. And equally, on the other end, when you remove an algorithm, you want to keep the receiving side, the checking the signature and decrypting in place longer than long after, depending upon the situation, very long after you remove the signing or the encrypting side. So there's a draft which you can read. I think where we are in that is introducing it to the community and asking for
investigation revealed that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area.
Thank you very much.
Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area.
Donc.
Attention. Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area. Attention.
No, it's not possible to get back to work.
Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is not.
All right. So the sequence of so the phases of an algorithm life cycle I've shown here at 7. One might have thought that you could get by with fewer, but the trouble comes principally at the tail end and a little bit at the beginning. The middle of it is you got a mainstream algorithm, and everybody agreed to that. And then there comes a point where there's a decision that this algorithm is going to go away. And what I'm showing here is that there are 3 steps to get rid of it. One is a declaration that it's going away, and then actions that follow from that. Why didn't this work? There we go. Did I do it right? Yeah. Okay. So here's 6 transitions. These are the spaces between the phases. So decision points A, B, C through F, and criteria associated with each of those, which I'll show you quickly in a minute. and the relationship between using an algorithm for signing versus using an algorithm for validating. Same kind of issues if you're going to use an algorithm for encryption versus decryption. One of the messages here is, if you look at the bottom where it says mandatory to implement, that's introducing the validation early and keeping it for a long time, even after it has been recommended for phasing out and marked as deprecated, should not be in use, top right. But during that same period, still having the validation working in case things are still trickling in. So those transition points, as I said, are labeled A through F, and here's quick definitions of them. In the interest of time, I'll just leave those there, but then suggest what the actions are. So those are the phases. And so what are the criteria for making those decisions? And I put in bold in each of these slides the IETF relevant part of this. So the first thing is, getting a identifier for an algorithm and saying, okay, we're going to have to pay attention to this going forward and publish that. That's the easy part. And then reaching some consensus that the algorithm is ready for use, meaning that enough deployment actually exists, and then publishing out a notice that the algorithm is available for signing in this case. So that raises the issue of how do you determine that the algorithm has been fully deployed and who makes that decision. Those two aspects involve processes to be defined, but I don't think that they are terribly complicated in principle. Once you are okay with the idea of having yet another group of experts that are assigned to this process and reach consensus and go through the usual IETF processes and the integration with an IANA registry and all that entails. Mainstream is more of the same. Phase out, a formal announcement that it's time to phase out, and that's the signal that operators should transition away from this algorithm to begin signing with some other mainstream algorithm. And then a formal declaration of deprecation, publish a notice that the algorithm for signing is inappropriate, but obviously that will not cause everyone all at once to stop using it. So then there is a period of time where things sit in this deprecation period. And then finally, it's okay to take it out. It's basically if you think of it as campfire, you've poured water on it, you've waited a considerable period of time, you've poured more water on it, and now you're finally convinced that it's okay to walk away from the campfire and you won't have a fire springing up. I did look at RFC 8624 and tried to align the criteria there with the phases that I've outlined here. Partial but not perfect alignment, and tried to map it in the other direction. So the question which I posed at the beginning, is this an area that this group is willing to take on? There's a process that has to go forward, obviously. I should say clearly, the kind of timeframes we're talking about are measured in years and decades rather than in to move from one phase to another. These algorithms live for a long period of time. The people who are likely to make the decision to remove an algorithm probably won't be the same people who decided to put it in the first place. I mean, we're talking about quite substantial periods of time involved in all of this. So formalizing all of this and getting it going will be a service to our successors more than it will be to us personally. Thank you.
Paul Hoffman, quick question. When you said officially announced, the IETF officially announces, is your picture that's done with RFCs, IANA registry, something else, or is that open until we discuss this in the working group?
Well, I'll choose door 3. When changes are made to a registry, what is the standard process for announcing those changes? Well, then that's the answer.
So my question would be, is this only DNSSEC related? Shouldn't we just take this to the security area or CFRG or something? Because it feels like this is like, it applies to more protocols than just DNSSEC.
I agree with you. And having thought about it a little bit further since putting these slides together, I think there's some more text and advice to be written about using this model, using this picture to manage the transition from one algorithm to another, so that it's not only a question of phasing out one algorithm, but that means that you'd better have the other one in shape to be ready. And that advice, I think, will be very helpful to vendors and to operators and so forth. But to your point about, isn't this more general and perhaps belong in the security area? Yes. Now the question is getting their attention and whether it makes the problem bigger and harder to solve, or whether or not that's the right way to go. I'm neutral about this. I haven't been actively involved in each of the areas, so I can see both sides of it. Taking a hint from RFC 8624, the focus there was specifically on DNSSEC, and there may be value in doing the spade work to put this together in this context, and then, alerting our friends in the security area. I have a lot of affection for the security area. I was the first director.
Steve, Russ Housley, your co-author. The security area directors tried to do this in the broader context and were unable to get consensus. So we're hoping we can get consensus in the smaller, focused on one protocol for view.
So,
thank you, Russ.
Victor, just be brief, please.
Okay, wanted to mention that there are good reasons why DNSSEC is special here. We don't negotiate protocols signing protocols directly with the resolvers. DNS is essentially data at rest because it is signed in one place and invalidated in another. Changes the picture dramatically. So algorithm life cycles for TLS are very different than those from DNS. And the expertise to decide about these life cycle stages is largely about knowledge of what the ecosystem is like, rather than the state of the algorithms from a security perspective. We need to know what resolver implementations are doing, what people signing are doing, what various hosting providers are doing. It's much more research of what's out in the field than it is about crypto research about algorithm security.
Yeah, quite an excellent point, which when you say it, I should have realized. If you have negotiation, then a lot of this gets collapsed and tightened up considerably.
Thank you.
Thank you. Yeah. Thank you. And yeah, please continue discussion on the mailing list. I think we got good feedback from the room.
Good.
And we wait for the discussion on the mailing list and keep in contact with you for either a call for adoption or other ways to make progress.
Thank you.
Yeah.
And thank you, everyone. Appreciate it. Thanks.
Jim.
Thanks very much, Andre. Hopefully this is going to be short and should be mostly a no-brainer for everybody. The intention we have behind this draft is to try and update or replace RFC 8806. Next slide, please. Oh, there's a button. Which one do I press? This one.
Oh, the one that's not visible because it's.
Okay. Yeah, there you go. Oops. Oh, right, yeah. There we go. So as we know, the hyperlocal idea was first documented. Thank you, Paul. As we know, the idea for hyperlocal has been around for a while, 10 years ago since the first RFC was written up on this. And the idea behind that is that resolving name servers hold a copy of the root zone. And the result of that should then be the end users get faster resolution. There's more robustness, fewer moving parts, or there's a little more complexity for the operators of those servers. And we also get improved privacy because the whole query name doesn't necessarily make its way all the way to the root. We'll also hopefully get reduced load on the root server system because a lot of queries being enhanced by local resolving servers rather than going out to the root. And from my point of view, we're also potentially going to see a reduced concern from governance circles because, broadly speaking, any organisation or government that wants to have a root server can effectively get one, albeit it's going to be through this resolver mechanism. And I think that can be very, very useful in some geopolitical contexts, not necessarily a concern for the IETF, but still a concern nonetheless. So the issue we have is that although RFC 8806 has been out for now 5 years or so, there hasn't been much in terms of adoption. Lots of people who are involved in this process, either as ISPs or DNS service providers and developers, seem reluctant to push this thing forward. The general attitude seems to be, this is only an informational RFC, so what's the point? Why should we bother doing it? So myself and my co-authors thought it's now maybe time to sort of move the needle a little bit more and replace 8806 with a document that could at least be a BCP, best common practice. But since the document has been published, we've had other comments, and a few people have come back to us and said maybe this would be better as a standards track RFC rather than a BCP. Personally, I'm neutral on this. Either's quite happy. I'm quite happy with either approach there. So what we're hoping to do here is get working group adoption for this document, work on it, and then get it to the stage to become a new RFC, and then we can all have a big party at the end of it because we've succeeded in doing something useful. But more importantly, once we have that BCP or standards track document, there's probably more of an incentive and encouragement on all the other players in this space to take this idea more seriously than they have to date. If it's a standards track document, it's harder to say, well, we are not going to implement that, we're not going to support it. Maybe the same thing would apply with the BCP. I don't know. But still, I think it would make a difference. So we know there's a number of gaps in the document as it stands just now, and there are a bunch of implementations that will need to be taken care of. For example, if we're going to make the root zone available for all the resolver servers on the planet, there's going to need an infrastructure behind that to support transfer of the zone, either through zone transfers or HTTPS or other kind of mechanisms like that. Who's going to stand up the platform to make that happen? Now, we've had indications that some people are actually willing to help us do that, but again, we need a document to try and help move that thing forward there. We'll also need to, for the fact that we need some way of verifying the contents of the root zone that other third parties are distributing. Zone MD is probably good enough for that. And of course, the root zone is signed. So the chances are that people could stand up a bogus copy of the root zone and have other people adopt it. It's still possible, but it's unlikely to be a serious concern. I also think there might be some extra considerations here for IANA and PTI, because if there are other parties involved in this distribution chain, maybe IANA will need some kind of oversight of what those organizations are doing and how. Maybe we need to define service levels for it as well. Obviously, there'll be some education and outreach, not so much in an IETF setting, but in lots of places where policy people gather, because as soon as you start talking about root server stuff, people get very, very, very excited and concerned about it. You know, the sky will fall in if you make any change to the route. So we need to try and explain this thing is not essentially going to be innocuous in the final analysis of it. And also want to then encourage the DNS providers and suppliers to think about turning this stuff on and actually incorporating it into the release maps and the release cycles. Most of the open source DNS implementation, resolver implementations already have support for this. It's just not switched on by default. It would be nice if we could change that situation. And with that, I'm done, open for questions and comments, and wait for people to start throwing rotten fruit at me.
Hi, Ray Bellis, ISC. I am a root server operator, just so people know that. I'm strongly against making this a BCP. I'm absolutely fine with the technical mechanism. I use it myself at home. My concern with the BCP is that by doing so, you're actually affecting an architectural change to the DNS. And that puts this in IAB area, not this working group's area, in my view. Just one other comment on, I think, on one of your first slides, you're talking about reduced load on the root server system. Yes, that's technically true. As a root server operator, I don't care. We have plenty of capacity. Capacity of the root server system is there for DDoS protection, and the current business as usual traffic loads we get are absolutely no problem whatsoever.
Yeah, I appreciate you say that, Ray. One thing that concerns me about the existing root server systems infrastructure is that we will at some point in the future, hopefully never, but I'm pretty certain going to happen, we're going to see a massive DDoS attacks against the root. And I question if all of the root server system operators can actually withstand that kind of traffic if it's coming from nation state actors. So you can say, yes, we've got defense in depth just now, and it's more than enough to cope with the existing nastiness that happens. But I think at some point we have to realize that those attacks are going to get bigger and nastier, and we need more defenses to them.
I agree entirely that we need to make sure that the system can cope against DDoS. But I think that's completely orthogonal to the question about whether the standard DNS queries to the root are an issue in terms of the load. They simply are not.
Okay.
Yeah, it's a non sequitur as far as I'm concerned in the context of this draft.
Okay.
Just because of the attention, we are running a little bit late, so please, everybody be brief. There's still...
Joe Abley. I think this is fine. I don't know that BCP is my favorite, but I'm not against it. I think it's probably fine. I think the other things that are missing from the draft are advice to implementers and operators about the monitoring and particularly stale data precautions that people need in order to do this safely. I think the current implementations in bind and things like that are great, but I think you should write them down so that future implementers and operators don't accidentally end up with stale data that can't be seen through third-party monitoring.
Yeah, good point. And I think Wes wants to interject.
If I can answer that as a co-author, the next version actually will have some of that.
Fixed in the next release.
Hi, Dwayne Muscles from VeriSign. So I think Ray kind of said already what I was going to say, that I have pretty significant concerns that if this becomes widely deployed, it makes it very hard to evolve the root zone, to add new protocol features, maybe even new record types and that kind of thing. We would have to wonder, what would be the impact to all those unknown resolvers out there that are taking the root zone that way. And somewhat ironically, there's already been an example of this, because when ZoneMD was deployed to the root zone in 2023, some processes at the 1.1.1 resolver failed to recognize the new record type. And about 2 weeks later, when the signatures expired, that's when they found out that there was a problem. So I have other concerns, but in the interest of time, I'll yield to other people.
Okay. Thanks for that point, Dwayne.
Ralphie Wakama, so thanks a lot for doing this. I'm okay with BCP, whatever also. One thing I want to note is that for this becoming default, we have to have a mechanism defined where all the resolvers should get that, and that has to scale, because, I mean, again, we have an implementation of that, but we sort of, until now, haven't done it on by default because of that.
Yeah, we recognize that, and that's something that will be either in the next release of the document or the one after it. Thanks.
I agree with what Ralph said and others as well. But my main observation is that the document 7706 and then 8806 describe something completely different than what was actually implemented by software. So I think that this group perhaps should stop saying software developers to do for deployment. For protocol, that's fine, but this document doesn't say anything about protocol changes or anything at all. So my suggestion is leave this to DNSORG or some other group which actually does operations, because this group is named DNS operations, but it's not operations like at all. So please don't.
Okay. Guess that's it. Oh, no more.
Okay.
Nobody else?
There was no more questions. Thank you, Jim. Please continue the discussion on the mailing list.
Okay.
We have heard different opinions, so it's good to have this discussion continued on the mailing list. Start. There hasn't been any. Thank you. Yep.
So, Johan.
Who's up next?
Johan.
Johan. That's the button to move the slides forward.
Thank you. Sorry, senior moment.
I'll start the timer for 20 minutes.
Yeah, that's fine. Okay. So, Oh, that one is very small. So I'm last, so I can actually put it at the right height. My name is Johan, and I work for the Swedish Registry, and I have actually 3 drafts to present here and now. So I will try to be brief so that I don't keep you from lunch, etc. The first one is the simplest one. This is about utilizing the newly standardized desync record to announce the existence of so-called CDS or C-Sync scanners. I presented this in Madrid, and I said it was a very simple idea, but still quite useful to, well, to child operators beneath a parent that does scanning, or possibly even child operators beneath a parent that doesn't do scanning, because it's not really easy to know every time whether your parent does scanning or not. So that's really one of the things we want to change. Speaking of changes, well, while this was a simple idea, we sort of changed it a bit. So in the previous version of the draft, we did some overloading of the semantics of the right-hand side of the desync record. So we were reusing the port field, and we were reusing the target field to signal existence and or non-existence of scanners and the frequency of how often the scanner runs, etc. That was not a good idea, so we stopped doing that. What we do instead is that we put extra information, like for instance how often the scanner runs, at an SVCB record at the target of the desync record. So there is a desync with the new desync scheme scanner. That's an indication that there is a scanner. And if there is a scanner, you can look at the scanner IIS-SE in my example here, the target of the desync record for an SVCB, where you will find additional information about this scanner. And one such example is how often it runs. I should also point out that all of this is about setting expectations in the child end. It's not about protocol change, it's not about software change, it's only about setting expectations, because without any kind of signaling mechanism, it's just not possible for the child to know what's going on or not going on. So the existence of this record, the scanner scheme desync record, says there is a scanner, and then we can signal things like how often it runs. However, there's more stuff. So again, using the Swedish Registry as an example here, we provide automatic DNSOP bootstrapping using RFC 8078 semantics. However, now we have a new RFC 9615 that essentially does the same thing, but through a different mechanism. And suddenly it starts becoming a bit messy what the parent scanner supports or doesn't support, if any, of these mechanisms. So we added, So we added another field here to the scanner information SVCB record, where we say we support the following bootstrap mechanism, and you can see that at the bottom there. And that's more or less it for this draft. So if we summarize it, we added a new desync scheme called scanner that essentially announces the existence of a scanner. We moved all the details down into an SVCB record instead. We added a mechanism for announcing support for multiple bootstrap mechanisms. And then I'm just pointing out that now with desync, it's possible to have a notify receiver that is sort of receiving notifications from children that are publishing CDS or C-Sync records. And that is sort of orthogonal to whether you run a scanner or not. It's quite possible to run a receiver without running a scanner, and you can run a scanner without running a receiver. And because of that, we need the same kind of signaling also in the notify scheme, which is what you see at the bottom there. And that's it. Then we have a second draft. And these are sort of similar in what updates and changes we've made. So I will just go through both of them, and you will see the similarities. We have this older draft about how to do automatic delegation synchronization, as in how to, from the child side, automatically synchronize the delegation information in the parent through dynamic updates. And this is not anything new. We're just making it slightly more, well, achievable and slightly more possible to use in a standardized way. However, we put that on hold for a while because we were waiting for the desync record to be published as a standard, which happened about a month ago. So now it's time to revive this. And just to set context here, we are not in any way inventing the mechanism of doing delegation information updates through dynamic updates. We've had that for a very, very long time. So I going back to Momoka's comment about 3901 being 20 years old and stuff changes, well, here's something which is even older. So we've had that for a very long time, but it was sort of hard to use. And it's the hard to use parts that we are actually addressing here in this draft. The first hard to use part is where to send the dynamic update. And we solve that through the desync record. That's sort of what the desync record is designed to help with. And the second thing that the draft does is it describes scalable mechanisms for automatic bootstrapping of the child 60 key in the parent. So the dynamic update stuff by itself is old and standardized. We're only making sort of infrastructure around it to make it useful in practice. So speaking of bootstrapping, that has been one of the major discussion items, and for good reason, because that's obviously sort of the key of the matter here. If the parent trusts the child 60 key, the child can use this private key to sign updates and they will be validated and trusted by the parent. So that's good. If the parent doesn't trust the key, well, it doesn't work. So this is very, very important. And in the previous version of the draft, we implemented, or rather documented, semantics similar to 8078, which is essentially you query from multiple vantage points around the internet over multiple times and over TCP, and you verify that it's consistent over time and space. And if you do this sufficiently many times, it's very likely that it's actually correct. So we already have that. But now we also have 9615, which is about publishing. Well, in the 9615 case, it's about publishing the CDS record as the magic name underneath the name server name, which is in the DNSSEC signed part of the hierarchy. So you can do a DNSSEC validation of this data and thereby trust it. So we can obviously do the same thing because we are publishing a 60 public key, which is sort of the same problem. Right. It really looks like the same problem. So how should we tell the children about this? Well, it's nice to be able to do several things in the same way. So we do exactly what I described a couple of minutes ago in the scanner and notify schemes, but now we do it for the desync update scheme, where we also publish an SVCB record at the target of the desync record. And here we see that we have the same bootstrap problem. This is sort of not really complete, because if you look at it, you can see that it says bootstrap at apex. That's essentially what 8078 describes. And then it says bootstrap at NS, which is essentially what 9615 describes. And in the previous examples with notifying scanner, I make RFC references instead. That's not bright. So I was apparently asleep at the wheel there. So my guess is that it's really, really stupid to refer to an RFC, because RFCs can be updated. And also, it's not good to refer to an RFC in one case and something else in the other case, because in the other case, there is no RFC to refer to. So I think we should just use the same tokens here. So I suggest we go with it at apex and at NS in all these cases, and then they become even more similar. Another advantage, which I will not go into details about, is that moving this information that the parent publishes about what bootstrap mechanisms do I support, etc., into stuff that the parent publishes in DNS, means that we don't have to have that negotiation sort of in private through an EDNS 0 option, which we did before. And that simplifies this EDNS 0 option communication, which has other implementation simplification advantages. So it's a win-win. And that's the summary of this. It's essentially a very small change. It's very, very similar to what we did with the scanner and the notify schemes. And it's about moving the information down into an SVCB record, supporting new bootstrap mechanisms, and some other simplification. And that's that. Are there any questions?
Victor, go ahead.
The SIG0 bootstrapping, is it tofu or is the child authenticated somehow? Because it smells a little like Dane, but I'm not sure what it is.
Let's see, I'm probably very stupid, but I didn't understand the question. You asked whether it was child authenticated.
Whether the child provides any cryptographic proof that that SIG0 key is the right one. Yes.
So I'm the child, and I realized that my parent supports updates through this update mechanism. That means I need to create a cryptographic key pair, a private key and a public key. The private key is obviously mine. The question is, where should I publish the public key in a way that the parent can trust it? And the mechanism described in 9615 is that I publish this key underneath the name of one of the authoritative servers that are in a DNSSEC signed part of the namespace. So the authentication is based on DNSSEC down to that published SIG0 key. Is that an answer to your question?
Mostly. I'm just wondering why it's not Dane, but okay.
Well, we could do it in other ways, but this is the way that we are doing it right now.
Okay.
Any other questions?
I actually do have a question for the room here. It feels like this is a very specific itch to scratch. Is there, because this is for the TLDs mostly?
This is for all parents with unsigned children.
Yeah, but how many these are out there that are not TLDs and are?
That's mostly the TLDs, obviously. Yeah. Most of the children in the world are children of TLDs.
So this is the question for the room. Is there enough interest to actually push this ahead? Because if we talk about this and there's not enough people to review this, and then it's not going to go forward anywhere. So, like, who's interested in this except Johan? Okay, like 4 people in the room.
Yeah, but you also have to look at this from the point of view of, A, we already have the mechanism. The only thing we essentially need is a code point in the desync registry. Second, we have more than 90% of the children today are unsigned. So CDS and csync automation simply doesn't help them. This would. So just because there isn't an enormous pent-up demand for this doesn't mean that there isn't a use for this. It just means that people haven't realized this.
I'm not disputing that. I'm just like saying there needs to be enough people who will work on that.
Yeah.
So Wes Herdiger, and you know, author of the csync draft and heavily involved in the development of CDS and discussions. Both of these two technologies help, you know, the resiliency of the entire DNS ecosystem. So I'm willing to review and help participate, at least in the discussions, because they're critical technologies to a large extent. We know that there is a lack of cohesion between parent and children now. Let's fix that. So I'm willing to help. Can't speak for the rest of the room.
Thanks, Wes. Okay, thank you. Next presentation. So this one, I should start by apologizing for the rather sad state of this draft. The reason for the rather sad state of the draft is that this started out as a rather simple thing, which we called opportunistic transport signaling. And then we had lots of feedback, and we had lots of feedback, and we had lots of interest. And the thing sort of exploded in our hands after the OARC meeting in Stockholm a couple of weeks ago. And we simply did not have time to sort of bring all the chickens home again to make it into a well-polished document. So this is very much work in progress, so to speak. That said, we can talk about where we are and where we're heading and what is happening, etc., because there seems to be a lot of interest about this. So if we start with the previous presentation, well, the simple idea was that you attach an SVCB containing transport signaling information to responses from an authoritative server. That means that the authoritative server is making a statement on its own behalf. So I'm sending a query to ns.provider.example, and I get some sort of response. And by the way, this name server, this authoritative name server says, oh, by the way, I support DNS over QUIC, and I support DNS over TLS, for instance. And then I can choose whether I want to use this or not. It's typically not validated. It's just provided in the additional section. It may not be there, even though the name server tries to say this to me, because it could be stripped off in transit. But if it gets there, I have a signal. And if it gets there, I may even have an RRSig on that, which enables me to actually do validation and thereby increase the trustworthiness of the information. So why do we want this signal? I mean, there is already an RFC with a number that I have very lots of difficulties remembering the number of. I think it's 9539, which is essentially blind probing. And the difference between this and that is that once you have a signal, you can do more things. For instance, you can distinguish between test and production. But by publishing this record, I say, this is production. This is something where I want to have traffic to this name server over this transport, rather than just happens to respond over QUIC, even though that's just a quick test, quick test, that I'm doing right now, but I intend to turn off in an hour. If there is a signal, we can upgrade the quality of the signal by signing it, etc. So there are certain advantages to actually having a signal rather than not have it. So if we look at this from the point of view of, let's call it the space of problems here, we have on the x-axis, we have different kinds of transports. Starting with clear text, we have private transport as encrypted transport. We have encrypted and authenticated transport. And at the far right, we have something that we depend sufficiently on not to have clear text fallback. On the y-axis, we go from the blind probing, the unvalidated signal, we validate the stuff, and we essentially, in the end, we validate the signal chain. Deleg is obviously up in the right-hand corner here, because there's everything is good, but we, well, don't have Deleg quite yet. So where are we in this space? Well, we're about here, or rather, we started here with the opportunistic mode. We do get privacy, and we have an unvalidated signal. So if we move onwards with this, based on the feedback that we got, what happens? Well, it's clear that people are interested in a validated signal. Because with a validated signal, suddenly we can express more things. For instance, we can express things that would be dangerous to trust if you don't have a validated signal. And that means that we are essentially moving in the direction of, in addition to the opportunistic signaling, which we already have and that works, etc., we are adding a second mode, which we call validated mode. And in the validated mode, we typically query explicitly for the record. It has to be DNSSEC signed, and because it's DNSSEC signed, if it validates and everything is good, we can actually trust all the contents in there, in spite of whether they are dangerous or not. What do I mean with a dangerous signal? Well, one example here is what we right now called the -DO53 signal, which is a way of turning off UDP and TCP transport. And the point here is not that it has to be a negative signal. We could do this in other ways. For instance, we could say that you should always include a positive DO53 if you support the UDP and TCP, or not include it when you turn it off. So the exact mechanism of how to do this is a detail. The important thing is to be able to say, I do not support something, in addition to being able to say, I do support something. Why would I want that? Well, I would want that sometime in the far future when perhaps not every name server should or want to support UDP and TCP, because a lot of traffic has moved to more modern transports. Another example is I want to turn on DNS over QUIC, but I don't want to compromise my existing service over TCP and UDP. So I want to have the new server only do QUIC, and the old servers only do UDP and TCP. And I want to separate this. And that means that I need to be able to somehow say that this new name server over here, it does support DOQ, but it does not support DO53. So I need this mechanism to be able to divide up my traffic so that my testing and my evaluation of whether I can shift traffic to a different transport becomes as clean and transparent as possible, not mixing all the traffic modes together in the same servers. Another sort of cute possible case that we came up with a couple of weeks ago is that, okay, let's say that you have unicast servers. Many of us do. Sometimes these unicast servers actually have to be down for maintenance. So for the Swedish registry, we do have several unicast servers run by external providers. When they take one of those unicast servers down for maintenance, they need to inform us in advance, saying we have a maintenance window and this will be 12 hours long, and sorry about that, but that happens. It's a unicast service. And we need to know this because obviously our monitoring will go red immediately when they turn it off. If we have this negative signal, it would be possible for that name server to in advance publish a -DO53 ALPN with a TTL of, let's say, 15 hours. And then all the recursive servers that touch this authoritative server, they will just sort of migrate away for the duration of this maintenance window, rather than to hit on it like once every 60 seconds or something. And all the monitoring would suddenly be good. And then when the maintenance window is over, they would migrate back again. That's rather nice. It's not a reason for this signal, but it shows the usefulness of having signals. So what else? Well, as we're moving in the direction of more validated mode transport signaling, obviously we would like to be able to validate the certificate used. We would like to be able to validate the addresses of the name server. And whether we do that in a single SVCB with all sorts of stuff in it and an RRSIG, whether we do that in the, let's call it more traditional way with separate records and multiple queries, that's a matter of choice. And we can do it either which way. The important thing is that we're moving in the direction of actually validating this information. But it's also rather obvious that now we are sort of starting to overlap a bit with the NS revalidation proposal. We look at more things because we also look at transport, but there are other parts that overlap. And that means that we have it sort of on us to realign terminology and overlapping aims, etc., so that we don't talk about different things. So we've recognized that, and we need to do that. And just to wrap up, this is where we were, and this is sort of where we're heading. And that's it. Questions?
So because of the announcements, we are going to run over the time a little bit. So Joe, go ahead.
Yeah, Joe Avley. This is a quick one. I think this is good. I don't think this is in conflict with DELEG. We can have both things. I think this is a nice short-term option.
Yeah.
And I think, like, you obviously need support on the resolver side as well. But certainly on the authoritative side, I think this is something that Cloudflare would like to work on. So I think interop is important. I think the working group should pick it up.
Obviously, the complexity is on the resolver side, as always. But as I've said before, and as we hope, we're trying to keep the transport signaling as close to DELEG as possible to minimize the sort of redundant work. It won't be perfect, but there will be some overlap so that code can be reused, and if experiences in particular can be reused.
Yeah, it turns out we also have a recursive service too. So
yeah. Ralph.
So
sorry, Andre.
So with my chair hat, I think for this draft to go ahead, it needs the implementers to be on board with this. So removing the head and putting an implementer head, it is very hard for me to find a motivation to implement this instead of just like working on DELEG, because there's just so many things we have to implement and we have to fix in bind, that having yet another method when we are heading to have DELEG is I can't justify myself finding time for this. So go ahead.
Ralph Wakama, so expanding on this. So we don't implement the probing, and I don't think we have any interest in implementing this for a couple of reasons. First of all, you're kind of with this increasing the size of packets that are sent back and forth, which will not be used by a lot of stuff. This is just, inefficient, in my point of view. But also, it is not that the resolver, when it gets a packet because it has ask and auth, just willy-nilly goes to something and can do something else. There is a delegation and iteration process, and it's very hard to integrate it into that because you are. That's the beauty of DELEG. You have a normal process where you have an authenticated signal that sends you somewhere. And the third thing is putting anything in the additional section, and then years later found out it is abused, is a history. That the DNS is very, very, very. Used to. So we should stop putting stuff in additional section and believing just by sending stuff people can do it. We should follow the regular path of it. So that's why we're not going to implement it.
I mostly agree with this. The part of the additional section, and as you can see here, where we're heading towards an authenticated mode where there is an explicit query instead. So we're in agreement there. And I already forgot your previous comment, but the problem here is not that this is in any way in conflict with DELEG. Everyone agrees that DELEG is a better solution, absolutely. However, it's also further away. And the question is, should we do nothing while waiting for DELEG, or should we do something? And that's a separate discussion, really, but it really is the discussion.
Yes, and
I'm
I think
sorry,
what
but we are over
Andre,
time.
I said was that the complexity that in the resolver doesn't justify.
Let's continue the discussion, the mailing list, please.
Thank you.
Thank you. Thank you, Johan. Sorry, Victor, we are out of time. So summarizing. So one thing I heard is the first two drafts presented by Johan. It's a small group that think it's important. I haven't consulted with Andre, but I think we should continue that discussion. That it will be a small focus group working on that with commitment, and then we discuss it also on the mailing list. But if it's really important, then we should go forward with the drafts. So that's about the two first drafts, Johan. Further, before closing, on Thursday, There will be DNS at the IETF session in the ops area. So it's Thursday, the third session of the day, if I'm correct. So our AD Matt started with Wes a mailing list, discussion mailing list. So everyone in the room, there's a mailing list with this discussion going on. Thank you, Wes. So talk with Wes, talk with Matt about the ideas, read the mailing list, and go to the ops area meeting, session 3 on Thursday. Thank you all. Thank you for your patience. We're running out 5 minutes, but well, we did a great job furthermore. Thank you. And now in French.
Donc,